Welcome to part 2 of Competency 14 quiz. In this video, we will continue working with probability distributions. Number 6, the amount of soda dispensed in a paper cup of an automatic machine has a mean of 6.2 ounces and a standard deviation of 0.4 ounces. What percent of all paper cups will have between 5 and 7 ounces of soda? Okay, if you look at number 7, I've already penciled in a few facts about the empirical uh, rule for the standard deviation. There are percentages that are used. Okay, for this problem, we are going to use one digit behind the decimal point. Okay, now on the side, notice that the first two, we have 68% and 95%. Those are often used. So the reality is, for a good exam question, you need to identify or define what you want the student to use for the problem. Whatever you're using in class is what you need to use on the exam, or whatever your book is using. And for this book, that's what I'm doing. I'm using one digit behind the decimal as already established. Okay, just making that clear because it does make a difference. Okay, so what else do we need? Well, we need to find the z-score. So we have to have that formula. And if you remember, that is going to be your x, and that's given here with our 5 and our 7, minus our mean, our mu, and then over the standard deviation. Okay, well, we have all that. Here's our mean we need, standard deviation. Now we need to go capture those z-scores. Okay, so let's set up a fraction. 5 minus the 6.2 over the 0.4. Okay, for the 5, that gives us minus 3. Okay, now I've already set that up here. Okay, all right, now I'm going to go back up. I'm going to do a type over. So I'm highlighting so I can capture. So press enter. I've captured my setup. I'm going to go over my 5. It's highlighted, type 7, enter, and that gives me 2. Now that's not what we have here on the tail end. This is what I need. So what I need to do is figure out what that, let's say, range is. Okay, so how do I handle that? Well, what I did was I did some subtracting. I subtracted, let me show you in my calculator. I'm going to clear that out. I took 99.7, then I subtracted my 95.5, my two percentages. I'm using the 9 the 99.7 and then the next one up. Those are the two things that we're using, our z-scores, our standard deviations way. So I'm going with those entire from -2 to 2 and -3 to 3. Okay, that being said, what did I get? Okay, let's enter. And I'm going to clear this out so you can see what I'm doing. Okay, that's the difference between the two. But remember, that's two-tailed. So I need to get rid of, I'm going to change colors here. Let me change this color. Let's go something bright. I need to get rid of all of this little tail here because I just want from -3, and I didn't write that down, to 2. Remember, 7 was 2. So I need to go from -3 to 2 right here. I've already stated that. So I need to get rid of that little tail. So I will need to do some subtracting away from 99.7. Well, I've got a two-tail situation. Well, how do I figure out what that one tail is I need to get rid of? Well, just divide by 2. Okay, so I need to subtract 2.2 from my 99.7. Let's check this out here. 99.7 minus 2.1. Voila, it's A. Now, please remember there's more than one way to do this. There's more than one option to solve this. We only have a scientific calculator, and it's best for you to remember these percentages. Now, if I went with my two different ones that you see for the empirical rule, meaning for us it would be 95%, we would get something different. So let me show you what that would be. 99.7 minus only 95%, okay? And then that's 4.7, divide that by 2, and that gives me 2.35. Now let's subtract that tail that I have highlighted. Let's subtract that off. Okay, so I have 99.7 and minus, I'm going to go back up and capture all of it, enter. I love that capture, it saves some time. And enter, and that would be my estimation, which isn't even in my A, B, C, D options at all. So obviously A is what we needed. All right, let's take a look at number 7. Okay, all right, now let's look at number 7. Find the z-scores for the center region area of 95.5. Oh goodness, we already answered that question. Yeah. Okay, so from here to here, that's the 95. So that would be from -2 to 2. Okay. Now remember, if we are in the middle, I'll change colors here. If we're from -1 to 1, okay, you need to remember that that is what percent? 68 point. Now, I do need to say something about that because we're about to do some questions with that. You need to be very aware that sometimes in these problems, when you don't have a TI-84, when you're using the type of calculator we are, be that the XS or the XB, okay, on your test, it'll be the emulation, it will say 30XS. It is exactly what we're using here. I just use this one because I like the green color. Doesn't matter, okay? They will change that from uh, 68% or 68.3, or I have seen 68.2. Okay. Now, let's see. We have already said 99.7 from -3 to 3. Very common. Okay. All right. And remember, it never crosses the x-axis, which you would have seen in the prior video. Okay, what are we leaving out? Let's see, we have this one is the 95.5. Okay, sometimes that might be, or, okay, I just realized I need to put that point there. Okay, 95.45%. Okay, so that being said, be careful with that on some of these problems. That's why you're going to get an approximation. Okay. You're not using the TI-84. Even then, you'll see a little bit of discrepancy here and there, as long as you get your values as close as you can. Now, what I didn't write down was from -3 to 3. That's on the prior question we used this. That would be 99.7. And rarely is that adjusted. So you can be pretty sure with that. Okay, now that I've said that, let's move on. Okay. Number 8. In a normally distributed population, the mean is 24 and the standard deviation is 4.8. Which one of the following is completely correct with reference to the distribution of sample means of all samples of size 64? Okay, the first thing that you need to remember, or the first property you need to acknowledge, is that this mean isn't going to change. That's one of the unique properties as you uh, get your samples. Okay, so we have to stay with 24. Okay, so that is going to get rid of B and D. Okay, that gets rid of those two. Now, let's take a look at your standard deviation. That's what's going to change. And we have a quick little formula to change that. Okay. Well, that being said, you already know, okay, this is your standard deviation that's given. You already know that A is not going to be an option. Okay. Remember, mean the same is always the same. It's the standard deviation that changes. So what is it going to change to? So your sample deviation is going to equal, okay, your S, which is your 4.8, because we're talking about a, a sample situation. So you're going to put, or not your S, your standard deviation from your population, okay? Then you have to use the square root of the sample size, which is 64. Okay, pop that in the calculator. All right, you get 4.8 over second radical, okay, 64, which would have been 8, guys, by the way. But let's go with accuracy, and that gives us, of course, verifying option C. All right, let's try number 9. Number 8. In a normally distributed population, the mean is 24 and the standard deviation is 4.8. Which one of the following is completely correct with reference to the distribution of sample means of all samples of size 64? Okay, the first thing that you need to remember, or the first property you need to acknowledge, is that this mean isn't going to change. That's one of the unique properties as you uh, get your samples. Okay, so we have to stay with 24. Okay, so that is going to get rid of B and D. Okay, that gets rid of those two. Now, let's take a look at your standard deviation. That's what's going to change. And we have a quick little formula to change that. Okay. Well, that being said, you already know, okay, this is your standard deviation that's given. You already know that A is not going to be an option. Okay. Remember, mean the same is always the same. It's the standard deviation that changes. So what is it going to change to? So your sample deviation is going to equal, okay, your S, which is your 4.8, because we're talking about a, a sample situation. So you're going to put, or not your S, your standard deviation from your population, okay? Then you have to use the square root of the sample size, which is 64. Okay, pop that in the calculator. All right, you get 4.8 over second radical, okay, 64, which would have been 8, guys, by the way. But let's go with accuracy, and that gives us, of course, verifying option C. All right, let's try number 9. Number 9, in thousands of dollars, the mean salary of all the high school teachers in Texas is 52, with a standard deviation of 3. What percent of these teachers earn more than $49,000? Okay. The key here is to notice very quickly in thousands of dollars, and that's why they gave you 52. So we are only going to use 49 when we calculate. So, a couple of things that we need to acknowledge. First, we need to see how far this is away from the mean of 52. So, what do? We set our fraction up and we subtract 49 minus the 52, that's a given, minus the 52. the new value of 49 minus the mean given. Okay, then divide by the value of the standard deviation. Okay, all right, now push enter, and that's a -1. Now think about it, that makes sense. It's going to be one standard deviation to the left. Okay, so if I draw that very quickly, okay, and again, pretend like I draw. We've got that mean going down the middle, and my z-score is 0, but the mean is 52. Okay, then over here, okay, I'm going to say -1, and that is my 49,000. Okay, so it's just to the left. But what does the question say? What percent of these teachers earn more than that? Okay, so what we need is this. We know that, here, let me use my highlighter here, over here. We know this is 50%, right? Okay. And we know that this from 0 to -1 is half of 68.3, or it could be 68.2. They always move that around, okay? Yeah, or rather move that decimal point either to 1 or 2 or 3, whatever. Let's just set up our fraction and get as close as we can. I already see one that looks good. I can tell you right now, I don't like C or D. Well, let's put that fraction in. Okay, well, not the fraction. The 50, we do have a fraction now. 50%, that's my yellow, plus the fraction of what? 68. Let's do 0.2. Okay. And then let's divide that by 2. Remember, we only want this half. Here, allow me to change this and show you. This little part right here is the half we're going to add to the yellow. Now, why are we doing that? Now, if you have paid attention to what I said prior in the video, from -1 over here to 1, remember, from here to here, what is this equal? Well, that's my 68.2. Okay, so I need half that, right? Because that's the empirical rule. Remember that. Okay, so let's push enter, and there we go. Option B. This is not a difficult question, but what the question is asking is, do you understand the empirical rule, and do you understand the overall normal distribution properties? That's all it is. So if you can kind of work with a few of those simple questions, you will be absolutely fine. Okay? All right, let's look at number 10. A baker is deciding how many batches of muffins to bake to sell in his bakery. He wants to make enough to sell to everyone, but no fewer. Through observation, the baker has established a probability distribution in the table. What is the mean, which is mu? Remember, this is our notation for mean, and the variance. Okay, that's our little squiggly q squared. Here, that's sigma actually. That is actually sigma variance. And then standard deviation is sigma alone. So that's under the square root. Okay, but our calculator doesn't give us variance, it gives us standard deviation. So if you didn't watch the other videos on how to get that, it's not a problem. This may seem like a crazy complex question, but they gave us a table, which for us made it amazingly simple. Okay, so getting this done in 3 minutes is not a big deal. Okay, so I am going to push data. Now I've already got my data populated. So I want to push data again and go up to number 4, push 4. Okay, all right, now we need to enter 1, 2, 3, 4. Remember, this is a frequency table. All right. Okay, now go over to 1. And then remember, did you see I just used the right arrow and it just popped up where I needed it? 0.15, enter. 0.35, enter. 0.4, the calculator does it for you, so don't worry about putting in all those zeros mess, okay? All right, so 0.1, enter, and we are good. Now we have it populated. Okay, now I have said before, be careful going straight to second stat because sometimes the calculator wants to put the information in the cell you have highlighted. Okay, so it is best practice to say second mode to get all the way out and then second data. Okay, we want number one because we are not doing an XY variable in this situation. This is a frequency table. How often did these things occur? Now we want to go get our information from these occurrences, okay? So do not mistake this with your XY coordinates, okay? All right. So let's push enter. Okay, everything is set up correctly. I have L1 populated and L2. See where like I said, it's frequency. That's why we have FQR. So number 2 or L2 is all the frequencies. Okay, so let's push enter, enter again until we get it. Okay, so our mean is number 2. That's number 2. So anything that isn't 2.45, which is C, that is not an option. Okay, now what do we need next? We'll just arrow down. Okay, so looks like now this is a sample standard deviation. So it is going to say this is how the calculator reads it. It's sigma x. Okay, don't worry about that notation. Right, that's just a calculator thing. Okay, in your brain to say, don't worry about it. Okay, but that tells me that B is good. A is no longer an option. And actually, D is no longer an option. But you know what? Let's verify this value. Okay. How do we do that? All right. Go up, highlight where it says number 4, press enter. And it gave it to me. Now, you're like, wait a minute. It just put the symbols in there. If you've watched the other videos with me, you know that the calculator is holding it for you. Now, that is our standard deviation. We want the variance. How do we get variance? This is what we do. Simply push square and enter. Okay, now it gives me a nice fraction. Remember, you have a toggle button. And there you go. Okay, option B. Okay, don't be fooled by this simple little calculator. It will do so much more. Yes, you do have to remember more than if you were using your TI-84, but it's highly effective and convenient little calculator once you learn all of its little bells and whistles. Okay, I teach with it all the time at the college and I just love it. Of course, my students enter and they're really upset. They're like, oh, this calculator won't do me any good. So they don't want to get it at first. They don't want to go, like buy one on Amazon or go check one out. We have the ability to check it out at the college. And they get all upset until we get about 3 days in. Okay. And then the sparks start flying and they understand what I'm doing and they're just like, oh my gosh, I could who no one told me this. So don't hesitate to go buy yourself one of these. Target has them on sale during back to school and at other times. Okay, now Amazon is amazing. I got a cute little pink one. Okay. Now I have seen them in purple. It's really rare. You can get this green that you see, this pretty little green on my screen. go and just go on the internet and shop around, find a different color, get what makes you feel good. Okay. For me, I change it up. I have a little calculator collection, and as time goes on, yes, I know I'm ranting about my calculators, but your best chance of getting through this test quickly and accurately is with the ability to use your calculator. Get it done, move on, and make your life what you want it. Okay? All right, let's look at number 11. In a small city in Texas, a survey of 16 schools was conducted to determine the number of teachers in each school. The results showed a mean of 35 with a sample standard deviation of 5. Assuming that the population of the number of teachers in each school is normally distributed, what is the 90% confidence level of the mean number of teachers in all Texas schools? Okay, for this one, we're going to use our little expression. Remember, it's plus or minus where your mean is, okay? And before we do that, you need to look at your A, B, C, D options and look at which ones don't make sense. B does not make sense. Why? Because this is not less than this. Just look at your whole numbers and eliminate some options. Okay, now I'm looking at C, and you got to be kidding me. The mean is 35. It has to be in the middle of whatever values you get. Okay, these aren't even close to the values in C. Let's look at D. Okay, this is crazy. That makes no sense whatsoever. So if you had looked at those, you would have seen right away. It's got to be A. Okay? And yes, it does. But we're going to prove that it's A. Okay? So this is what we need. We need 35 plus or minus. Now, you need that 90% confidence Z score, and that is 1.645. Okay. Then times, okay, that other expression, which would be your standard deviation over the square root of the number of your samples, or rather your sample size, which is 16, which of course the square root of 16 is 4. Correct? Absolutely. But I don't want to worry about that. I just want to type it in into my calculator, and I'm going to select the minus first, okay? So let's clear this out. 35 minus 1.645, parentheses, and my fraction, 5 over second radical 16, arrow over, parentheses, and enter. And yes, I have verified the first value. Now, don't, like I've done before and I've stated before, do not retype the whole thing. Go up, highlight to capture, push enter, you've captured. Now, remember my other trick. Arrow up, arrow down, and you're at the first. Now go over and type over a plus, enter, and you have verified the second value. Now notice in the second value, we have a slight discrepancy. Okay, don't worry about that in this situation. And even in the other one, we had a slight discrepancy, and that is because of our Z score here. Those items were probably obtained from a TI 84, and that's probably where they got the values from. Now, I've actually estimated those in different ways, okay? Because you know that your Z scores are going to be a little bit over 99.7 from -3 to 3, correct? So I've done this. If you want to play around with it, you know what your normal distribution is and you understand the properties. I've taken, because you can't say 100%. So I've said, okay, what if my z-score, instead of from 3 to 3, it's going to be greater than 3. So I've done 3.5 and then divide that by 2 and push enter. Okay, and I've used that. Now look at the difference in 1.645 and 0.75. So I kind of like estimated it, and you know what? I got close enough to get my answer correct. Okay. All right, this is the last question in this video, and you're amazing for getting to the end of the video and listening to my ranting about the calculator. Go ahead and invest in it, or go online and type in TI 30XS emulator free. You will find one. Use that one on your computer while you work with items on the side so you can go faster. The faster you are at typing these in and the less you write, the more time you save, and then when you get to the harder questions that you're stumped on, you have that few extra moments. So you get through all the questions and it gives you a fighting chance. Okay. All right, guys. Thanks for liking, subscribing, and sharing. You guys are the best. Happy testing.